morning guys. I will share my screen. So first of all, what is the reason we are going to study about earthing system? Due to which reason the earthing will created? If what is the reason the shock will be created? If shock will be created in the sense, what is the reason we are going to provide earthing? How to provide earthing? How many types we have? Like that we will discuss. After that we will move to ETAP part. Okay. So just consider if some of the places in transmission tower or otherwise any other substation. Okay. If any fault current will occur in the sense, in that places electric shock can be created. Okay. For example, just consider I am considering one of the transmission tower. Okay. So in the transmission tower, if any fault occur in the sense, so that time the fault current will be created, right? So if the fault current will be created in the sense, we need to ground this kind of fault current. Okay. So that is the reason we are going to use the part as grounding, or otherwise some person will call it as earthing. Okay. So for that reason only we are going to use that earthing system or ground grid system in the sense, if we are using earthing only, we can able to increase the human safety. Okay. If we are not providing earthing in the sense, electric shock will be continuously created in the sense, we cannot able to provide a safety for that human, right? So that is the reason only we are going to provide the earthing. So under the earthing we have many types. Just consider, I will share one of the things in that through images. Okay. So earthing will provided in mat manner as well as earth pit manner. Like that manner they will provide in a different manner. Just consider, using earthing they will be provided as a mat, earth mat. Some professional will called as a earth mat. Okay. Under earthing, one more thing is a pit type. Okay. Pit type and then rod type. Like that we have many types. Okay. Mat in the sense, can you see here? This is one of the copper conductors only. Can you see here? This is a mat type. So here I am using how many rows and then columns. That we need to assign in that mat type. Based on the fault current, you need to assign how many rows and columns we are going to use. Okay. Can you see here? Apart from this mat also, can you see here bottom of the mat you are having one more copper conductor, that is rods. Can you see here? That is ground rods. It is comes under rod type. Okay. If number of rods will be increased in the sense, we can able to reduce the resistivity. So based on the conductor size, how many rods you are going to use, based on that we can able to reduce the resistivity. Okay. So why we are going to reduce the resistivity? Like that we will discuss while we are using in that ETAP software. Okay. So now you just see which one is mat type, which one is rod type. Okay. Why? Because in that ETAP software, first we are going to discuss using mat type, that is using conductor alone. Okay. So first we are going to use conductors, that is mat type. In using mat type, how much resistance we are getting? After that, if I am going to include a rod in that conductor in the sense, how much resistance, step potential, touch potential we are going to get. Like that we are going to see in that ETAP software. Okay. Can you see here copper conductors, that is earth mat. Okay. If they are placed a rod in that copper conductor in the sense, it will comes under ground rods, rod type. Okay. So based on the fault current, They will provide only for earth mat, or otherwise they are going to use ground rods also. So based on the fault current, it will differ. Okay. So next thing is, in that earthing part, you need to know what is the step potential and then touch potential. Okay. So first of all, I will discuss what is earth potential and then touch potential. So in this earthing, you need to know which one is step potential and then touch potential. So due to that reason only we are going to provide earthing. Okay. So for that you need to know what is step potential and then touch potential. So first I will discuss what is a step potential. Okay. Just consider. So here also I am considering same example, that is a transmission tower. Okay. So just consider one of the transmission tower or otherwise any substation. Okay. So in this we will discuss what is step potential. So step potential, which is nothing but voltage difference between feet of the person. Feet of the person. So just consider, here I am considering one of the transmission tower. Okay. If any fault occur or otherwise induced voltage, something, if any problem occur in the sense, automatically fault current will create. Okay. For that I will share one more image. For the step potential, I will share one more image here. Okay. Just see this image. Can you see here? This is my transmission tower. Okay. In this tower, if any fault occur in the sense, automatically fault current will create, right? So if I want the fault current will flow through this transmission tower to ground. Okay. Just see, if fault current occur in the sense, the fault current will flow through this transmission tower to grounding. Okay. While moving the fault current from transmission tower to grounding in that time, okay, in that time, if any fault occur in that grounding wires, or if any ground wire will cut in the sense, in that time, okay, while fault current flow from transmission tower to grounding part, in that time if any wire, grounding part wire will be damaged, or grounding wires will be cut in the sense, in that time if any one of the person walk at the place, in that means that time they will sense electric shock. Okay. So why? Because they won't touch that electric wire, but they will feel the shock. Why? Because see here, due to that, what is the reason? What is the reason behind due to feel the electric shock in the sense? This due to that step potential only. Okay. Just see here. Can you see the voltage difference between feet of the person is called as step potential. Okay. When the person walk while the fault current created, and then while the fault current flow through the transmission tower to grounding, in that time if any grounding wires will damaged, in the sense, in that time if the person will walk, in the sense, that time they will feel shock. Okay. So what is the reason? In the sense, due to that step potential only. Okay. So potential difference between two feet is called as step potential. So what is the reason we need to calculate step potential? For earthing system, we are going to see that step potential as well as touch potential in the ETAP software. So what is the reason we are going to check that step potential, touch potential in the sense due to that reason. Okay. So that is the reason only we are due to step potential only the person feel the shock, right? So due to that reason only we are going to calculate the step potential as well as step touch potential. Okay. So what is the reason we are going to calculate the potential difference, that is step potential difference in the sense, just consider in which place. So can you see here in that feet difference between the 2 feet only voltage difference occur, right? In which place the potential difference occur, in that place only the current will flow. Okay, can you see here? In which place the current is flow, in the sense in that which place we have potential difference, in that place only the current will flow. So current will flow in that least resistance path only. Due to that reason only we are calculating step potential. Just consider normally in the transmission lines birds will set on that transmission lines, right? But in that time it won't feel shock. Why? Because just consider this is my transmission line. In this transmission line, one of the bird is sit on the transmission line, in the sense the leg is like this manner. So in between the distance is very low. Okay. So the distance is very low, in the sense the potential difference also very low. Okay. So the potential difference is very low, in the sense the current will not flow through this one. That is the reason while the birds will placed on the transmission line, it won't feel the shock. Okay. While the person walk through in that place, in the sense the potential difference is created. So due to that potential difference, the current is flowed here. That is the reason the human feel the shock. Okay. So we need to check that step potential. So what is the tolerance value? So inside this, in between the tolerance value only, we can able to get the step potential. If the step potential will very high, more than tolerance value, in the sense how to reduce that step potential, touch potential, that we are going to discuss using ETAP software. Okay, guys. So now itself we are discuss step potential, right? Next I am going to discuss touch potential. So touch potential, which is indicates a voltage between difference between person and then feet. Sorry, voltage difference between energized object and the person feet. For example, I will show same design. Okay, same image. Can you see here? So which is a touch voltage, which is indicates, just see here, if some of the person without safety elements, that is personal protective equipment without safety elements, if they touch that element, in the sense or energized element, that is a transmission tower while the fault current occur, that time energized element, in the sense that time they feel shock. Why? Because touch potential, which is indicates energized object and then the person feet, that is called as touch potential. For that also we need to calculate the touch potential. Okay, can you see here earth mat? In that, while providing earth mat, if any wire cut or otherwise any damage occur, in the sense that time only the person feel electric shock. Okay, So to provide the earthing, we need to consider step potential and then touch potential. So that value will be comes under the tolerance values. If it will be exceed tolerance value in the sense how to reduce using rods, using include the rods like that. Okay. So, and then one more thing, how you are mentioned the tolerance value, the maximum value. In the sense, for that only we are going to use two method. So here I mentioned, here we are going to calculate what is step potential, touch potential. That is okay. Apart from that, here we are going to here we are going to check if it is comes under tolerance values or otherwise it is exceeds the tolerance value. Like that here I mentioned, right? So here how we are mentioned the tolerance value in the sense for that we are going to use two method, that is IEEE method and then finite element method. Using these two elements, automatically ETAP software will provide the tolerance limit values. This much limit only we can get for this fault current like that. Okay. So under this thing we are going to discuss IEEE method and then one more thing is FEM, that is called as finite element method. Multiple ways we can able to check this thing under our ETAP software. First I will discuss IEEE and then finite element method. After that I will discuss how to do earthing using design. First I will going to discuss without design. Why? Because if the client will provide a directly fault current in the sense how to do the earthing. Like that only first I am going to discuss. If the client didn't give any fault current, just they provide only design. Using that design only I am going to create, we need to create everything in the sense how to do. Like that we will discuss step by step manner. Okay. So first I will start from IEEE method. Okay. So for this IEEE method also we have the tolerance value. ETAP software automatically will provide the maximum value for based on the fault current. Okay. Mainly they will consider resistance. Mainly they will consider resistance. Okay. So maximum the resistivity value will less than 2 ohms. Maximum. Maximum in the sense 80% of clients companies. They will expect 2, 2 point something or otherwise less than 2 ohms. Okay. Some other companies they will provide less than 3 or otherwise less than 4 ohms. Okay. So based on the clients, the resistance value will differ. Okay. So maximum they will expect less than 2 or otherwise less than 3 only. Okay, maximum less than 3 ohms. Some of the clients they will give the rating as maximum 4 ohms or otherwise 5 ohms like that. Okay. So we need to consider step potential, touch potential as well as resistance values also. In real time, if they want to, if we want to check the current flow in that electronic components, voltage flow in that electronic components, we are using multimeter, right? Like that in that earthing part, in that real time, they will use one more element to check the resistivity. Okay. If the resistivity very high in the sense that time what they will placed while earthing time in the sense they will use coal. Okay. They will use coal as well as soil as well as water as well as salt. Okay. These things they will use to reduce the resistivity. Okay. In that substation while they are using earthing, while they are going to do earthing in that substation places in the sense to reduce the resistivity, they will use nearly um, more than 10 kilo coal or otherwise 15 kilo, 20 kilo, and then they will use one tanker lorry water to reduce the resistivity based on the fault current. Okay. So to reduce the resistivity in that real time, Why? Because while they are going to assign the grounding, after placing the grounding, that is conductor, that is earthing mat as well as a rod, they will place coal and then soil and then salt, again soil, and then coal, salt, like that they will placed, they will assigned inside the ground. After that, in between they will they will put a water also. Okay, some of the places, if the fault current is very low, in the sense, after filling coal, soil and salt, finally they will assign the water. Some other places, in between itself, they will include the water. Why? Because after that we are not going to open that earthing part, right? If any fault, if any problem occur, that time only they are going to open what is the open and then see the fault. So that is the reason they will provide a water and then coal, soil, salt to reduce the resistivity. Okay. So now I am moving to ETAP software section. So in this part, first I will discuss about IEEE method. Okay. So here I opened a new project. So in that IEEE method, first I'm going to discuss without ground rods. Just I'm going to use only that earth matter, that is conductors. After that, in that same design, I'm going to discuss with the ground rods. You can able to see the difference without ground rods and then with the ground rods, like that. In that outputs, you can able to see the difference. So already the client gave the fault current. For that I'm going to do the design. Without, I'm not going to do any design like cables, loads, grid, transformers, generators. I'm not going to use any any other elements. I'm just going to use only earthing part. Earthing part. Why? Because already client gave the fault current to us. So for that I'm going to draw. So in this AC elements, you have the option as ground grid. Pick and place this ground grid in your screen. Just expand length and height of the grid based on your convenient. Okay. Double click that grid. While you are double clicking the grid, you can get one more pop-up. Using that pop-up, you can able to select which type you are going to consider, IEEE method or otherwise finite element method. Now I am going to discuss IEEE method. Give OK. So in this IEEE itself, we will discuss without ground rods and then with the ground rods. After that, we will discuss finite element. In that also, we will discuss without the ground rods and then with the ground rods. So if you are giving OK, one more pop-up window will create, that is ground grid system. Grid 1 page. So this is considered as a soil. Okay. This is 3D view. In this place, you can able to see the 3D view. This is a top view place. After assigning the values, you can able to see the 3D and then top. Soil, 3D view and then top view. Double click that soil. Okay. Can you see here? Material, top layer, lower layer. Already I told in that real time they will place coal, soil as well as a salt and then water like that, right? So which type of soil you are going to use, in which places you are going to assign the soil, like that we need to assign here. Okay. So here I am considering the material as crushed rock. The soil as crushed rock. In that place, which type you are going to use, which type of material you are going to use, based on that you can select here. Okay. Plain limestone or otherwise gravel, like that. So here I am selected crushed rock. Crushed rock resistivity, as already they provide maximum how much resistivity we need to assign. They will assign us 2500. So some of the client will provide maximum resistivity. So based on that only here I place the all values. So this grounding system client values which is given by substation designing clients. This part, this is done in one of the substation. Okay. So that material resistivity maximum 2500 ohm. So next thing is, after placing rocks, some other moisture soil. The soil type will be, I'm going to use which type of soil I'm going to use. Moisture type or otherwise a dry type, like that. So based on the location, it will differ. Okay. In our country, earthing will different manner. Resistivity will less than 2 or otherwise less than 4 ohms, like that. If you are moving any other countries, in the sense, in that place, the resistivity will differ. In some other countries, they will use maximum less than 7% like that. Okay. See here, if directly you are using moisture soil, in the sense, no need to use waters. Just you can able to provide lightly water. Okay. If you are using dry soil, in the sense, compulsory you need to provide water separately. Okay. So based on that, you can select the material. Here I am going to use the type as moisture soil. For that, the resistivity is 400. So how much a distance I am going to use this crushed rock? Here I am going to mention the depth of that crushed rock. I am going to use the crushed rock meter is 0.102 meter, which is given by client. Otherwise, if you are going to use more meters, in the sense, you can change the values here. Okay. So how much ohms the crushed rock moisture soil we have, that I need to mention here. Okay. Not only we are going to use in that single place. We are not going to use the soil in that single place. While the ground level reaches, that time itself we are going to place soil, salt, water, coal, like that. Again soil, water, salt and then coal. Like that manner we are going to fill up to lower level to top layer. Okay. Just consider this is my ground. This is my ground. Okay. This much distance I am going to use. So in this place only I placed that conductor. That is earth mat. After that I am going to use rods. Okay, so maximum level here. Lower level is here. Rod is placed up to this distance. Earth mat is placed. How many rows and columns I assigned? Based on the resistivity, you can able to change the number of rows and columns. After placing the mat and then rods, we have distance, right? This much distance. In this much distance, you can able to assign coal, soil, water, salt, again coal, soil. Which type of soil you are going to use based on that. Okay. So this much itself you need to place. Okay. If you want to change the depth of the meter, if client didn't give the values in the sense, you can able to change. Okay. Why? Because we have this much distance, right? In that distance, you can able to assign. Here I only mentioned the crust rock meter only. Okay. Give. So the values are fed here in the soil place. Okay. After placing the soil values, click here. Can you see here right side all the elements in comes under disable type. In this top you just click the cursor. The options are enabled. Okay. Now I am going to use rectangle shape copper conductors, that is earth mat. Okay. You can able to change the shape of the conductors, that is earth mat. Okay. Pick and place in the top view. Can you see here? I placed in that top view position. You can able to see here 3D view. In the soil also you can able to see. Okay. After placing the conductor, that is earth mat, we are going to assign the conductors, right? How many conductors we are going to assign? That we need to mention. Okay. How much a distance I am going to create? In that image itself you can able to see. I think this all the things same design. Okay. How many distance? Can you see here? Length and height of that earth mat. How many conductors I am going to use? That we need to assign. Okay. So in the top view, just double click. You can get IEEE group editor pop-up window. Here you have conductors as well as rods. Okay. Now I am going to discuss only conductors part. I am not going to use now rods. So give under arrangement as no ground rods. Okay. Without ground rods only, now I am going to check. So give no ground rods under arrangement. Okay. In that same design, I will discuss with the ground rods also. Now go to conductors. So here I am going to use this much distance. The client provided already how much a distance you need to assign that earth mat. In between that only you can create that much conductors like that. Okay. Some of the client won't give the distance. Okay. Based on that fault current, you can change. So here I am going to use a minimum fault current only. Okay. So the grid size, that is earth mat sizes. Length and height of the earth mat is 70 meter. Can you see here 70 meter? Just assume. Why? Because this is substation design. Okay. So based on that, they are providing the distance. Based on that fault current also. So length and height of the earth mat is 70 meter. So in between the 70-meter earth mat, I am going to use number of conductors. Copper conductors is 11 for X direction as well as Y direction. Okay. So after assigning the number of conductors, just move to conductors part. Here I want to change this depth. Here I am using only 0.5 meters for this conductor. Okay. Just see here. I placed this earth mat copper conductors, right? Here I am having ground earth mat. In between this, we have 0.5 depth. Okay. That I mentioned here 0.5. Okay. The copper conductor square mm. Normally, if we are considering cable sizing in the sense, inside the cable we have copper, right? The copper or otherwise aluminum conductor, we have square mm, right? Like that. How much square mm we are going to use the conductor size? Here I am going to use 35 square mm based on my fault current, which is given by client. Already I know what is the fault current. Okay. Based on that, I am going to use the square mm as 35. If fault current is very high in the sense, you need to change the square mm of that conductor. Okay. The conductor type is which type I am going to use? I am going to use copper clad steel rod. Here we have many types, right? Here I am going to use copper clad steel rod. While you are checking the design, that time you can check any other types also. Okay. Which type you are going to use? Compared to aluminum, copper conductor will the conductivity will be very high. So that is the reason here I am using copper clad steel rod. If you are using instead of copper clad, if you are using aluminum in the sense, you need to assign this for that same design, you need to assign more square. So instead of 35, you need to assign 70 or 120 like that for that same design. Why? Because compared to copper, aluminum conductivity will low, right? That is the reason. If you want to change the cost of the conductor, you can change. I won't change here. Why? Because it does not affect our output. So I don't change the cost here. Okay. And then give OK. Can you see here? In the top view, number of conductors also increased in the row wise and then column wise. Totally, I gave 11, right? Okay. Once you check, it is 11 or like that. From started here, 3, 6, 9, 11. Okay. So in that y-axis also we are having 11. You can able to see in the 3D view also. So already I gave, I'm not going to use rods, right? So I disable that part. Now I'm going to use only that conductors. Now I'm going to run that ground grid steady. So the running option is here, ground grid steady. Just enable this option. You have the option edit study case toolbar. While you are running, that time the option is enabled. Just click that edit study case toolbar. In that page only we are going to assign that fault current value. Can you see here ground short circuit current? Here we have two options. One is user specified and another one is a short circuit steady. So now I'm going to mention under user specified. I'm only going to assign the fault current. Okay. From design, how to get that fault current directly, that I will discuss later. After finishing finite element method, I will discuss. So the ground fault current is, the client which is given to me is 3.18 kiloamps. Okay. If from that design I am getting 19 kiloamps or otherwise 17 kiloamps, 16 kiloamps, in the sense size of that conductor also differ, number of conductors also differ, length and height of the mat also differ. Okay. So manually I provide the fault current, and then for that fault current, the X by R ratio is 3.33. So while the client fault current directly give, in the sense directly they will provide X by R ratio. Okay. While we are assigning short circuit study, at that time you can understand. Okay. While from the design, automatically if I feed, in the sense automatically the X by R ratio will change. Okay. So after that, after providing this user defined fault current values, we need to check what is the weight and then temperature, which method we are going to use, like that. So here I am going to use IEEE 80 2000. Okay. Using this method only I am going to run. Based on that method, ETAP software will shows the tolerance, the limit values. Okay. So here we can able to assign weight of the person. Maximum capacity, here it shows 70 kilogram, right? So here I am going to assign maximum capacity. Weight of the person is 70 kilogram. Okay. 50 kilogram, in the sense some of the person weight will differ, right? That is the reason I am using 70 kilogram maximum weight. Okay. So here the ambient temperature is based on country, our country temperature. Our country temperature is 35 to 45 degrees Celsius. Here I am using 40 degrees Celsius. Based on the country, the temperature will differ. So don't change under this fault duration. Okay. Fault time, that is conductor time, like that. So in this, we need to change the factor as surface factor. Okay. So under grid current factors, we have the factor, two factors. That is surface factor. Another one is product correction factor. Okay. So here I am going to use the surface factor as 60%. Why? Because in that current, for example, if the fault current will created, in the sense we cannot able to surely 100%, we cannot able to surely assign this much fault current will created, like that, right? So here I am going to use the surface factor maximum, approximately 60%. Okay. So based on that surface factor, the output will affect. Based on the fault current, the output will affect. Based on the conductor square mm, the output will affect. Okay. The output will affect due to this kind of changes. Now give OK. Now I'm going to run the design ground grid calculation here. Using that you can able to check what is the step potential and then touch potential. Can you see here? Using that IEEE 80 2000, the tolerable limit value is touch and then step potential value is Touch potential value is 840.5. Step potential is 2696.1. Step potential comes under the tolerable limits, right? But touch potential is exceeds. So it will indicate the maximum touch voltage exceeds the tolerable limits. Can you see here resistivity? Resistivity will less than 3. Some of the client will provide less than 4 or 5 like that. Based on the country, the ohmic resistance will differ. Okay. So we need to give the solution for the touch potential. Okay. So already I told what is the reason we are calculating the step and then touch potential. While the potential difference occur, that places only the current will flow. So that is the reason we are calculating this kind of step and then touch potential. So how to give the solution for the touch potential? We need to get the values within the tolerable values. Okay. For that I'm going to use, already I provide conductors, mat type, right? Apart from that also I'm getting the touch voltages is maximum of the tolerable. So that is the reason I'm going to use rods. Okay. In that same design I'm going to use rods. Go to normal edit mode. Here you have the edit mode, normal edit mode. This is a running option, ground grid system, steady. Double click that mat, go to rods. In this arrangement, now I'm going to select the rod type. I'm going to use rods along grid perimeter. See here, if you are going to use only for grid corners, or grid corners which is indicates 1, 2, 3, 4, 4 grids corners only we are going to use. Or otherwise, in that grid itself, grid corner itself you are going to use. In that interiors only you are going to use. Like that you can able to select. Okay. So maximum the rods directly they won't use interior. First they will assign corner. After that only, if you are not getting in between the range, after that only they will include the rods inside the mats. Okay. So I'm going to use rods along grid perimeter. So how many rods I'm going to use? I'm going to use number of rods. So corn in all the places. Okay, not only for corners, outer side of the grid mat in that place I'm going to use. So maximum rods I'm going to use now 20. After that we will change. Okay, first I will check for the 20. Okay. The rod diameter is 2 centimeter. How much distance I'm going to use? Can you see here? If I'm using rod in the sense how much distance the rod is placed, that we need to mention in that software. So length of the rod I'm going to use the distance as 7.5. For this length also the output will affect. So instead of increasing length, you can increase the number of rods. Okay. For example, instead of using 15 meter, in 15 meter, you can use 10 rods is enough in the sense. Instead of that, here I'm going to use 7.5 meter, I'm going to use 20 rods. Okay. What is the type of that rod? Already we assigned a conductor type, right? Like that for that rod also we need to assign. Here also I'm going to use copper instead of aluminum. So here I am going to use copper annealed soft bronze. So conductor type, I used a copper clad steel rod. Some of the members, while they are using mat, right, in that place conductor, they will use copper clad steel wire. Steel wire like a strip. Okay, like a strip. So here I'm using annealed soft bronze. You can choose any other things. Okay. So number of rods 20, diameter 2 centimeter. How much distance I'm going to place the rod? Which type of rod here I'm going to use? In which places I'm going to use the assign the rods like that I mentioned. I didn't change the cost. If you want to change the cost of the rod, you can change. In the design itself, we are assigned the cost of the rod. Give OK. Can you see here? In that corners places, the rod is placed automatically. In that IEEE method, automatically it is placed. Can you see here? 1, 2, 3, 4, 5, 6, like that. One in the place, rod 1, 2, 3, 4, 5, 6. Okay, can you see the 3D view? If I'm using finite element method, in the sense manually only we need to place the rods. In this IEEE method, automatically it is placed based on the option. Okay, you can change the option while you are running. You can change the option. You can change the 3D view. Okay. In that time only you can able to see the differences. Now I'm going to run the design. Can you see here? It is now comes under tolerable limits. Okay. So if I'm just considering only mat in the sense, step potential only it is comes under the limit. Touch potential it's not comes under the limits. So that is the reason I'm going to include the rods. While I'm including the rods, after that I'm getting the two things comes under the limit values. So in this session, we will discuss about finite element method. For that also, I'm going to create new project. What all are the values I feed it in that IEEE method? Same values I'm going to use for the finite element method also. Okay. Double click. Pop-up window will open, ground grid design pop-up window will open. Select finite element method and then give OK. So now the page, the corresponding page will open. Same values I'm going to use in that soil. Okay. So here I'm going to use the material as crushed rock. After giving the material, change that resistivity as 2500. Okay. After changing the resistivity, don't change the material. After changing the material, change that resistivity. Okay. Moisture soil. For that moisture soil, they provide maximum 400 resistivity. So depth of the meter 0.102. And then give OK. So after giving the soil values, in that top view, just click here. Why? Because that time only you can able to get the option. Here I am going to use the same rectangle. You can able to change any other type also. Double click that rectangle, that is a React mat. You can get the pop-up. In that pop-up, we have group conductors. Here we are not having rods, right? Why? Because in this finite element method, manually only we are going to assign the rods. So that is the reason we are not having the option. So same grid size, I'm going to use 70 meter, length and height. Totally 11 conductors I'm going to use. 0.5 meter, size will be 35 square mm. If you are increasing the square mm, in the sense you can reduce the conductors like 9, 8 like that. Okay. Here I'm going to use copper annealed soft bronze. Last time I'm using a copper clad steel rod, right, for that conductor. Rod only I'm using this type, right? Now I'm using this type, copper annealed soft bronze. Insulation type of that conductor is I'm going to use bar type. This is one of the insulation type like rubber type insulation, XLPE type insulation like that. And then give OK. Now go run the design, go to edit study case, assign the fault current values and then wait temperatures. If you want to change the temperature in between 35 to 45 degrees Celsius, no issues. If you are going to run other countries, based on that, you need to change the temperature here. And then give OK. Now I'm going to run the design. Can you see here? Step potential is under the tolerable values, but the touch potential is high. So we need to reduce that one. Using rods, I'm going to reduce that one. Okay. So how to reduce that one? How to include the rods? Go to edit mode. Manually only we are going to assign the rods. You have the option first. Go to default, assign rods. Pop-up window will open. Defaultly, it will store the values. Okay. So which type of rod you are going to select? You can select here. Okay. Here I'm going to use copper clad steel rod. And then give OK. If you want to, just a minute, go to default rod. Can you see here? Length, how much distance? I'm going to place that rod. 3.05 meter. Okay. Give OK. So manually only we are going to place the rod. Which type of rod we are going to use, that already mentioned, using the default rod option. Just select that rod. I'm going to place the rod manually. Can you see here, while you are placing the rod in the 3D view, you can able to see. So I'm getting calculated value as 1093 something. Okay. After placing this top corner, top mats, I will check it is reduced or not. After that, I will increase the rods, number of rods. Save the design and then run and then check it is reduced or not. 1079. Okay. Line 35. After assigning outer side, after that include in inner side also. Okay. But don't directly give inner side first. Eight, 88. Eight 46. Now I will change the square mm. Okay, once we will check. Here we contact change the diameter, right? We will change the conductor square. In the IEEE method, we can able to change that rod type square mm also, right? So here we can able to change only conductor square mm alone. Can you see here? Now, instead of increasing the square mm, you can able to assign number of rods inside this conductors also. Okay, no issues. After running in this finite element method, you can able to check the graph itself also. So here I will mention first step pendant touch potential. Can you see here? All it comes under within the range, right? So step potential, so it shows only green color. Okay, touch potential also. So how much distance we are provided, like that we can able to see here. How the conductor is placed. This is top, we have mat. This is rods. Okay. If you are running with absolute voltage, in the sense, it will shows what is the maximum range. Like that it will shows. Over voltage limit also I will enable first. After that we will see what is the maximum range. It will shows the limit of that design also. If you are enabling that option. Can you see here? So the maximum limit here they are providing. What is the voltage? If in between this range, in the sense, the color is nearly brown. If you are enabling that voltage limits, it shows. For step as well as touch potential. If I want see that maximum voltage, in the sense, no issues. It is comes under normal limit only. Okay. So based on that, we need to assign the rods based on the step in the touch potential. Okay. If you are assigned the proper manner rods, in the sense, you can able to change the square mm also. Okay. So next we will discuss. Now itself we are discussed only if the client provide fault current. In the sense, based on that only we are drawn the design, right? Next we will discuss about using design. In that design we are getting fault current, right? For that, how to draw, how to do the earthing in that ETAP software. Like that we will discuss. In this session, I will discuss how to do the earthing process from the design. Last session itself discussed only if the client provide fault current value, in the sense, how to do that earthing, like that we discussed, right? Now we will discuss how to do the earthing using normal design. From that normal design, for that already I drawn normal design. First check load flow analysis. After that we will check short circuit analysis. We need to get the fault current right. So there is no critical or marginal condition while I'm running load flow analysis. Now I'm going to run short circuit analysis. So already I gave all the bus and the fault condition. Okay. So that is the reason we are getting all the buses brown color, which is indicates all the buses under fault. Okay. So see why some of the client will provide a fault current instead of giving design. Or otherwise, if you are run the design, in some places only we can get the earthing automatically. Defaultly, we can get the option. Okay. Instead of user specified, you can get the fault current from that design short circuit analysis. Okay. Just see here, I'm going to run the short circuit analysis. Okay. So all the fault current is stored, right? So in each and every buses. Okay. So here 63.356 kiloamps, 42.826 kiloamps, 19.839 kiloamps. So I'm going to assign the based on this fault current I'm going to create. Okay. Or otherwise, if you want to check based on the higher fault current, you can assign here, earth mat here, that is ground grid system here. So this is normal short circuit analysis, right? So how to feed the values inside the earthing? So first of all, I'm going to place the grid top of the bus. Then only I can able to understand, okay, for this fault current, we are creating the earthing. That is the reason I place the ground grid option top of the bus 3. Okay. Once run the short circuit analysis. Okay. Here I'm going to run three-phase fault. Okay. Here we are getting the fault current, right? Just to check the option is enabled or disabled. Okay. For which fault current we are getting the option. Like that you need to know, right? Here I'm running three-phase fault. Okay. So the fault current displayed normally. Okay. Just select the grid and then right click. Can you see here? Update fault kiloamps. Option is there, but it is disabled. Okay. For three-phase fault, we cannot able to update from this design. Manually only we can able to assign. After running the design, you can check the fault current. That fault current you need to assign in the earthing. Okay. If single phase fault, here I am going to assign single phase fault. Okay. Can you see here? Fault current is 14.059 kiloamps. Now select the grid, right click. Can you see here? Now the option is enabled. While you are running the design, if you are going to do the earthing for single phase fault current, in the sense directly you can take from that design. If you are going to do earthing for three-phase fault, in the sense you need to check the fault current from design itself. You cannot able to feed directly. Okay. From user specified option only you can able to assign. Okay, guys. So update fault kiloamps. Give update fault kiloamps. Now that pop-up window will open. Replace. Give replace. New value is 14 point. So for that automatically the X by R ratio is feeder. Give replace. Okay. While you are running, that time only select and then right click. Select the grid and then right click. Then only you can able to get this kind of options. Otherwise, you cannot able to get. Okay. While you are running short circuit analysis, that time select the grid and then right click. For single phase fault only, we will get the option. Three phase fault, we cannot able to get. For that, we can able to use user specified. Just already we seen 19 point something kiloamps, right? That kiloamps you need to assign in that user specified option. Okay. Now go to edit mode. Now double click the grid. I'm going to use IEEE method. Give OK. 19 something, right? So sorry, single phase. I mean line to ground fault. I'm getting 14 point something. Okay. Just go to running option. Edit steady case. Now go to short circuit study. Can you see here? For that fault current, what is the expiration? Automatically it is faded. Okay. Automatically it is faded. Using that, okay. Change that weight and then surface factor. So 19 point something in the sense here I'm going to use the material is crushed rock. Here I'm going to use 4000 something only. Okay. Here is Mr. Soil. Here I'm going to use the size is 300 square mm. Okay, for 3 kiloamps we are providing 35 square mm, right? So it is 6 times like that. That is the reason I'm using 300 square mm. Okay, here I'm going to use the grid sizes 90. Can you see here? Dependent touch potential value is exceed. Touch potential tolerable value is 929 only. But we are having 5000 something. But it will reduce. Why? Because it is nearestly 1000 volts only. Okay. For that we need to give more watts. We need to increase the size of the grid also. Nearly 90 meter only I am gave, right. I'm going to give 150 meter. Can you see here? Grid area is smaller than 6.25 square mm, greater than square. So here I am giving the square MMS very high rate. So 1200 we need to reach, right? Can you see here? So here we have maximum the square mm is 400 square mm, right? That is the reason maximum the area is 10 square meter. Okay. So 10.000 square meter. So here I'm giving the square meter is grid size is 150, I think, right? Can you see here 150 meter? So that is the reason it shows. If you want to reduce that, in the sense we need to increase the square mm here, but here we have only maximum up to 400 square mm. Okay, that is the reason I didn't include 400 square mm. Instead of that, here I change that grid size. Okay. If I want to reduce the grid size, in the sense I want to change the size of the conductor. Okay, that is the reason. Instead of changing this square mm maximum, here we have 400 only, right? That is the reason here I change that grid size. Okay, it is exits the level in that software. So instead of this size to change the square mm, here I'm using grid size. Changed the grid size. Okay. Can you see here? Now we didn't get the error. Okay. That limit error. Okay, guys. Can you see the difference? I think you can able to see the difference. Okay. So maximum it have this much square meter distance. Okay. If I exceeds that also, it will shows the error. So now I'm going to give the square mm as 400. Okay. 1384. So we can increase the number of rods. Option 338. So that is the reason I increased the size here. I will check with 120. Okay. Can you see? But it is comes under limit, right? I will give only 100 meter. $95. Only 10 voltage. Can you see here? Okay. So in which place we are getting error? What is the reason we are getting error? If we are getting warning or alarm indicates in the sense how to get the limits from that designing in between the limits, how to get the values like that we need to know. Okay guys. So in the session we discussed how to get the values from that design. From that design we can get only from single phase fault, sorry, line to ground fault only we can able to get. Okay. If I'm giving three phase to fault, three phase fault or otherwise double line to ground fault, manually only we need to assign the values in that earthing part. Okay.